I'm not going to talk a lot about project management. The entire unit is about project management, but I want to cover a couple of key players. Fred Brooks, Deming, Juran and Crosby. Fred Brooks, as I mentioned earlier, wrote Mythical Man Month. Adding manpower to a late software project only makes it later. There is no silver bullet, no single development in either technology or management which by itself promises even one order of magnitude improvement. To ask the question, how does a large software project get to be 1 year late? His answer was, one day at a time. Incremental slippages on many fronts eventually accumulate to produce a large overall delay. Continued attention to meeting small individual milestones is required at every level of management. Deming's opinion was to practice constant improvement and to imagine the manufacturing process as a seamless whole rather than as a system made up of incongruent parts. For Juran, the root cause of quality issues was the resistance to change and human relations. Juran focused on three processes: quality planning, quality control, and quality improvement. Crosby, his principle, doing it right the first time, was his answer to the quality crisis. He defined quality as a full and perfect conformance to the customer's requirements.
Three processes of this quality trilogy interact with each other. It all starts with quality planning, the process of establishing quality goals and developing the means for meeting those goals. Quality planning consists of a rather standardized series of steps as follows. Identify the customers, both external and internal. Determine customer needs. Develop product features which respond to customer needs. Products include both goods and services. Establish goals for those product features. Develop a process to meet the product goals. Prove that the process can meet the product goals under operating conditions. Once planning is complete, the process is turned over to the operating forces. Their job is quality control, to run the process and meet the planned product goals. Let me demonstrate with the help of a visual model. In this model, the horizontal scale is time. The vertical scale is quality in the negative sense of percent of product deficiencies, or cost of poor quality. What goes up is bad. The quality planning process is at the left-hand side of the model. At time zero, operations get underway. It soon becomes evident that product deficiencies abound. In this example, the products produced are deficient in various ways, resulting in a total of 20% deficiency. Why are the products deficient? Most usually, the deficiencies are traceable to the quality planning process. That planning process, for whatever reasons, has resulted in that high level of product deficiencies. In effect, it was planned that way. Under conventional organization structures, the operating forces do not have the responsibility and or the resources needed to replan the processes to get rid of the deficiencies. However, they do have the responsibility for quality control, and that is what they do. In simple language, the job of the operating forces is to maintain whatever quality level has been planned into the process. Their job also includes putting out fires, such as that sporadic spike on the model. Here, product efficiency soars to over 40%. The operating forces take steps to bring the quality level back to around 20%. The third process in the trilogy is quality improvement. In this model, the result of improvement is to reduce the chronic level of deficiencies from the original 20% down to a much lower level, in this case, about 3%.
To finish off this quick discussion about the leaders on project management and quality, I want to have a quick look at Kelly Johnson.
The next biplane was already taking shape in the mind of Kelly Johnson, interviewed here in 1975.
We knew that in overflying Russia for 4 years that they were making important advances in radar and missiles. And so in 1958, 2 years before Gary Powers was shot down, we decided we'd try to make a follow-on airplane, which became finally the SR-71, to fly higher and 4 times as fast.
What Kelly Johnson proposed was a leap into the future. Only 10 years earlier, man had broken the sound barrier. Now Johnson wanted to produce a warplane that could go 3 times that speed. At 2,000 miles per hour, no missile would be fast enough to catch it. He called this one the SR-71 Blackbird.
If anyone had asked an ordinary designer to build an airplane with the requirements that were laid out for the SR-71 at that time, they would have said it's impossible.
Every part of this warplane demanded brand new technologies. Its skin wouldn't be aluminium like the U-2, but titanium to withstand the heat generated at super high speeds. A unique liquid was created to act as both lubricant and fuel. Its shape was like nothing that had gone before. Skunk Works engineers completely redrafted the warplane blueprint. But by far the biggest challenge was the engine.
The designers faced the problem of having an engine that would work all the way from takeoff at 0 speed up through Mach 3.
No jet engine existed that could take the Blackbird where Kelly Johnson wanted it to go.
Turbojets are good at the lower speeds, but for good fuel efficiency at higher speeds you need a ramjet, where the air flows through the engine, is burned, and then goes out with the fewest obstructions possible.
In a conventional turbojet, air is squeezed into a combustion chamber by a series of compressors at the front of the engine, where it's ignited, creating thrust. Air entering a jet engine, travelling at twice the speed of sound, becomes compressed merely by the speed it enters the combustion chamber. The compressor discs of the turbojet become a hindrance to that fast-moving air.
In order to avoid putting both ramjets and turbojets separately in the same airplane and pay a big weight penalty, the genius of Pratt & Whitney was to add these bypass tubes around the core of the turbine.
At lower speeds, the turbojet engine is the power source, but at speeds over 1,600 miles per hour, bypass tubes divert the incoming air, creating a ramjet. Everything about Blackbird was done in secret. At Beale Air Force Base, Kelly Johnson and the top Air Force brass turned out to witness the latest and greatest warplane to join the Strategic Reconnaissance Wing, the SR-71 Blackbird. Test pilot Jim Eastham was one of the first to see how far the Blackbird would take him, and there was no holding it back.
We'll just let this thing cook and we'll see where it goes.
It wasn't long before Jim was doing over Mach 2.
Gee, the next thing you know, this thing clicked up to about 2.3. I said, maybe we're on to something. Just about the time we went back over our base, 3.0 showed up.
That day, Blackbird took Jim Eastham to Mach 3, over 2,000 miles per hour. Kelly Johnson's genius had lifted the Iron Curtain once again.